Sketch a graph of y is equal to 1/4 secant x. First off, what we're going to do is compare it to the original secant function and see what the transformations are. You see we have a 1/4 in the front. If we compare that to the general form of transformations for the secant, you can see that this corresponds to the a value in the front, which is corresponds to the vertical stretch or vertical expansion or compression. Because it's less than 1, it's 1/4, so that means we're going to be vertically compressed by a factor of 1/4. And so what this means is that all the points on the original secant graph, to transform it to the transformed version, all we have to do is multiply the y-coordinates by 1/4. And so I got the points from 0 to 2 pi of secant x. So and basically, because remember, secant x is 1 over cosine x, so you just find what's 1 over cosine 0, cosine pi over 4, 1 over cosine pi over 2, 1 over etc., etc. You can see we have asymptotes at pi over 2 and 3 pi over 2. And then I just divided all the y-coordinates by 4. So 1 became 1/4. 2 over root 2, if you divide that by 4, it becomes 1 over 2 root 2. The asymptote stays the same, and then it kind of just goes in negative values, but it's basically the same thing. So this is one period from 0 to 2 pi, as you can see here. It starts at 0, and you notice this y-coordinate is 0.25, and this one actually, if you put in your calculator, is 0.356, I think, or something like that. It's very little. It's less than 1, because remember, it's being vertically compressed, this new function. And so if I plug it in, my points, 0, pi over 4, pi over 2, which is the asymptote, 3 pi over 4, pi, etc., etc., this is going to be one period, and you'll notice it'll continue. If you plot points this way, it'll continue up, and then it'll be one that goes down, one that goes up, and it'll repeat just like that